For this example, we have to identify the key features of this parabola, and we're given the graph. I'm going to use it to determine and find all of these special features, beginning with the concavity. Now, because the parabola is facing down, I'm going to write concave down for concavity. If we didn't have the graph, keep in mind that the concavity is also determined by the a value. If the a value is negative, we have concave down. Let's move to the y-intercept and recall that the y-intercept is the point where the graph crosses the y-axis. And the y-axis is this line that I'm tracing with this red dot here. And we see that it's right here. The coordinates of this point are going to be 0, 6. And that's going to be the y-intercept. On the other hand, the x-intercept, we find those by looking at the points where the graph crossed through the x-axis, which is this line that I'm tracing with the red point. This is the horizontal line. And we can see that the x-intercepts are here at -3 and +1. Getting the coordinates, we have -3, 0 and 1, 0. Moving on to the axis of symmetry, that's the line that cuts the parabola equally in half. Here, I can create the axis of symmetry. Since my vertex is here at the maximum of the parabola, and this line cuts through -1. So here we have the line x equal to -1. That's going to be the axis of symmetry. The vertex, that's this point right here at the maximum. So the coordinate of the parabola is going to be -1, +8. Finally, to evaluate the function at -2, recall that whatever's inside of these parentheses, those are the x values. So we just have to look for -2 on the x-axis, and we can see that -2 is located right here. So let me go ahead and circle it. And now we just have to go and see where exactly the value of -2 is on the graph. And that happens at 6. So the f of -2 is equal to 6.